Hi, Mark.
Hey, Dave.
How are you today?
I'm good.
Good. All right, let's see. Which one of these do we want to start with? Other one?
Yeah.
I can't. Oh, yeah, here I see the numbering. All right, so we're doing surface areas and volumes. Which is interesting. That's the very last chapter in the book. So I'm kind of curious as to what you go on to after this, because I would think you guys will be done with this chapter by the end of March, easily. All right, let's see. Do we have anything specific on here that you want to talk about?
Let me look real quick.
Tell you what, let's talk about the volume or surface area of a right cylinder.
All right.
Just because that's a little bit of a hard concept to get. In other words, imagine that that's a soup can.
Okay.
The surface area is going to be the top and the bottom, right?
Yeah.
So that's R, the radius of the circle at the top. So the area of the bottom is pi r squared, same area of the top.
Okay.
So the surface area is 2 of the bases, 2 pi r squared, plus the area of the lateral part of the soup can.
Okay.
That's the part that's hard to understand, but think of it this way. Think if I had a label that just perfectly fit around that soup can, and I peeled the label off, it would have this shape, right?
Yeah.
Rectangular, where this would be the height. What's the distance from here to here?
That would be the length around the side of the soup can, right?
Well, what is that distance? In other words, if you think about it, if I had a label that perfectly fit, in other words, if I put it on the soup can, this edge matches up perfectly with that edge. What does that make this distance here?
The that's
the circumference of the circle.
Okay, so kind of like the perimeter.
Exactly, and that's 2 pi r. Okay, that's what circumference is. So the surface area of that label is h times 2 pi r. So there's the formula for surface area of a right cylinder. Just kind of think of, well, first of all, when we're talking surface areas of prisms, you know what a prism is, right?
Yeah.
This a prism?
Mm-hmm.
Yeah, because it's got 2 equal, opposite, and parallel bases. So all prisms, when you're talking about the surface area of any prism, it's going to be the area of 2 bases, capital B indicating that it's different than the base of a rectangle. In other words, let's just talk about that for a second, because that can be a little confusing. If I say, what's the area of this rectangle? You say it's the base times the height, right?
Yeah.
That's a little b, not a big B. And this is measured in, well, inches, feet, but it's a linear measurement.
Okay.
This little b here is not even close to the same as that b. Capital B means it's measured as an area.
Okay.
When I found the area of that circle, it was pi r squared. And that gives me square inches or square feet or square centimeters. So don't be confused by the little b and the big B. The big B is a measurement of area. The little b is a linear measurement of distance. But the surface area of any prism is the area of its two bases plus the lateral area. And I can just write it as LA, which could be all kinds of things. In other words, in a cylinder, that lateral area is the area of that label. But if it's a different kind of prism, maybe it has a regular pentagon instead of a circle as its base, it's different.
Okay.
And that's what this example here basically is talking about. Let me blow it up just a little bit. You can see that they give the general equation. Always start a problem with the general equation. Well, there's your two bases, 2 pi r squared, and there's your 2 pi r times h for the lateral area. And what they give you is the surface area and ask you about h. Well, if they give you the surface area and the radius, which they do, then you can plug it into this formula here, and there's only one missing variable, and that's h. And then it just becomes an algebra problem, not a geometry problem. Okay, let's do number 3. That's a problem.
Okay.
Let's have you try number 3. Find the surface area of a right cylinder with a height of 18 centimeters and a radius of 10 centimeters.
Okay.
In other words, radius is 10.
Yeah.
Height
And then the height is 18.
18. And they want the surface area. So start with the general.
Pi r squared.
It's 2 of them because there's a top and a bottom.
Oh, yeah. Oh, yeah. 2 pi r squared.
Plus.
Do we want to keep all this in terms of r?
No. In this question, they're asking for the surface area. So I'm going to fill in for everything, but I really think it's important to always start with the general formula. So what's the rest of the general formula? That covered the top and bottom, but what about the lateral area, the area that would be covered by a label?
Would that be HB?
No, it's H. Remember, if I tear that label off, I've got a rectangle.
Okay.
There's the H part of it. And you're right, it's little b, but what is little b? We have to figure out what little b is in terms of the cylinder.
Okay.
Right there. 2 pi RH. In other words, this distance is 2 pi r.
All right.
That distance is the same distance as the circumference of the circle, of this circle. Notice that if I had a label around it, it would have to be exactly 1 circumference in dimension. If it fits around just perfectly, where this side meets this side on the other end. That's the hardest part to understand here. So it's 2 pi r times h.
Okay.
Okay. Now they've given us the radius and they've given us h. So 2 pi times, help me fill it in.
2 pi 10 squared plus 2 pi 10 times 18.
Okay. And they said round it to 2 decimal places. All right, if they insist. I still prefer leaving everything in terms of pi, not changing it. Let's look at number 4. Starting with the general. In this case, they're looking to solve for radius. In other words, all of these problems are going to be pretty similar. If you have the radius and the height, you can figure out the surface area. Okay? So there's 3 main variables here. There's surface area, there's radius, and there's height. So they're always going to give you 2 out of the 3. And they want you to figure out the third one. So number 4, how should I fill in this? Starting with the general.
So just give you the equation. All right.
Well, there's the general.
So we already have the general equation. Yeah.
Okay, and what are they giving us in number 4? What information?
They give you the radius and the surface area.
Actually, they give you the height.
Oh, sorry. Yeah.
To solve for the radius. So tell me what I should write next.
You could do 208 pi r squared is equal to 2.
Hold on, stop one moment. 208 pi is the surface area.
Okay, yeah, sorry.
That's what I'm going to plug in for S. Now what? We don't know r, so I'll just for the moment leave it as r squared.
Yeah, plus 2 pi r 5.
Okay, now let's simplify that and see if we can solve for r. Now it just becomes kind of a tough algebra problem, although not that tough. What's the next step in solving this for r?
Just, you could simplify it, right?
Okay, you help me do the algebra here.
Okay.
I'm trying to solve for r. Let's whittle it down. Can we make the numbers at all smaller? Can we get rid of pi?
Yeah, I think so.
Well, we can certainly divide both sides by pi, for starters. And when I divide the right side by pi, I have to divide every term by pi.
Okay.
Okay. Now the pi's go away. That helps. And now we can divide everything by 2. So I end up with 104 equals r squared plus 5r.
All right.
Now what?
Well, could you do any more dividing on any side?
No, what are we looking at here? What is this called? It's called a quadratic.
Okay.
It's a quadratic because I have one of my variables is squared and the same variable is also in there not squared. So how do I solve a quadratic?
All right. You could subtract one of the r's from both sides, right?
No. The secret to solving a quadratic is to put 0 on one side and everything else on the other.
Okay.
So I'm going to subtract 104 from both sides, which leaves 0. You with me?
Yeah.
Okay, now I have to factor this in order to solve it. I mean, I could use the quadratic formula, but I suspect this factors. RR. What's the next step for factoring?
I don't remember much on this, but
Determining what both signs are. Okay?
okay.
Now,
Yeah.
unfortunately, almost every geometry problem you're going to come across is going to have some algebra in it. In other words, geometry merely allows you to formulate the equation. Solving it requires your algebra skills. So
Okay.
maybe that's what they're going to do after chapter 12 is go back and review algebra. Because this happens to most geometry students. By the time you've taken a year of geometry, a lot of them forget their algebra. Okay? So the way I'm going to factor this is I'm looking for factors of 104 that subtract, because of that negative sign, to the number 5.
All right.
Okay, hopefully we can find those. Let's figure out factors of 104. Well, there's one set. Let's cut that in half and double that. That's 52 and 2. Let's do it again. Cut this in half and double this. Notice how I'm doing factors here. And let's do it one more time. 13 and 8. We just found our two factors. Remember, we're looking for the factors that subtract to the number 5. Subtract because that is a negative sign. If that was a positive sign, we'd be looking for factors that added to this number. Okay, we found our factors, 13 and 8. Now the only thing left is to apply the larger of the factors, the 13, to the sign of the middle term. Well, the sign of the middle term is plus, so that's where I'm putting my 13.
Okay.
Okay. Now, that gives us what two answers for R? Remember, this started out as a problem where we have a right cylinder that they gave us the surface area and height, and we're trying to figure out the radius. Well, what's the next step? I get two answers. How do I solve this?
Well, I'm not sure, but what happened to the r squared?
It got factored out. In other words, once I factored this quadratic into these two linear factors, notice that if I multiply this thing back together again, what I get? If I FOIL it, I get r squared minus 8r plus 13r minus 104. Well, these two combine to plus 5r, which is what we started with. The key thing is when you have a quadratic, you have to get it into two linear factors. There's no way I can solve that in that form. But once I get it into this form, that's critical because there's a rule in algebra that says if you multiply two things together and they're equal to 0, well then one of those things has to be 0. You cannot find two numbers multiplying together to give 0 unless one of them is 0. So if I say
All right.
A times B equals 0, then my solution is, well, A equals 0 or B equals 0.
All right.
So how am I going to solve this?
Well, you could subtract 5 from 13.
No, in other words, here's what I've got. I've got two things multiplied together being equal to 0, right? There's one of the things
Yeah.
times that thing is equal to 0, so this has to be 0, r plus 13 has to be 0, or r minus 8 has to be 0. Okay, one of those.
Well, how do you tell which one?
Well, you get two solutions. But what happens? Let's solve it, and then we'll talk. You'll see how we tell. If r plus 13 equals 0, what's r?
R is negative 13.
And if r minus 8 is 0, what's r?
R is 8.
Which one of those is our answer?
8.
Correct, because you cannot have a negative radius. So
Okay.
whenever you're doing geometry problems and it comes down to quadratics always give you two answers. And most geometry problems, you get two answers, one of them is positive and one of them is negative. Well, dimensions can never be negative, just like time can't be negative. So you throw out your negative solutions. This rule of algebra, incidentally, that says when you have two things multiplied together, they're equal to 0, doesn't mean both of them have to be 0. It merely means at least one of them has to be 0. Otherwise, I wouldn't be able to get a 0 over here. And it's not just two things. It's any number of things. If I say A times B times C times F equals 0, well, one of those letters has to be 0. I don't know which one,
Okay.
but I know that they cannot all be non-zero, because there's no way I would get a 0. The only way you get a 0 from multiplication is if you multiply by 0.
Okay.
Okay, it might be good for us to spend some time reviewing quadratics. An awful lot of geometry problems involve quadratics, but not yet. Here, hold on. Let's go through your homework. It's number 6, a prism.
That was pretty easy, I think.
Okay. Tell me how you're going to do number 6. How are we going to find, first of all, is it a prism?
No.
Yes, it is. Remember what the definition of a prism is. Two opposite and equal faces. Well, that face right there is the same as that face right there, and they're parallel.
Okay.
And it's a right prism because everything's at right angles.
Okay.
So
Yeah.
to find the surface area of this prism, we basically are going to just find the area of every face. How many faces does it have?
1, 2, 3, 4, 6.
Yeah, all rectangular bricks have 6 faces. What's the area of this face, the front face that my hand is on there?
Wait, huh? Sorry.
That's all right. Hold on, let me. Can you see where I'm pointing?
Yeah, I can.
That face there, what's the area of that face? In other words, we got 6 faces. We're going to find the area of each face and add it all up, and that's going to be our total surface area. So what's the area?
Okay.
What's the area of this front face?
Well, the length is 8 and the height is 2, so the area is 16.
Okay, and there's 2 of them, right?
Yeah.
Okay. What's the area of this face, the darker blue?
That's just 6.
And there's 2 of those.
Mm-hmm.
And what's the final face? What are its dimensions?
24.
Okay, and there's 2 of those. So that's rectangular bricks are easy. 32 plus 12 plus 48, that's 92. Okay?
Okay.
When they
That's just the area?
find the lateral, they actually ask 2 questions here. They want the lateral area and the surface area. Well, we found the surface area. We found the area of every single surface. If you consider that's the top of the prism and the thing it's setting on is the bottom of the prism, then the lateral area is everything not counting the 2 bases. So it would be this face twice, and it would be this face twice, but it would not include that. They don't usually ask for lateral area of a brick because you'll notice that a rectangular solid actually is a prism by 3 different ways. It's a prism because that base has an equal and opposite face. This face has an equal and opposite face, and the top has an equal and opposite face. So a prism only needs 1 set. In other words, if we look at number 7, we won't do number 7. In fact, I'm going to have to run. I forgot I have a 5 o'clock. Mark, I will talk to you on Thursday, okay?
All right. Thanks, David.
All right. Bye-bye.